Hopefully you feel comfortable with arithmetic. Now we're moving on to geometric sequences. So a geometric sequence is a sequence in which the next term is found. Oops. I hate it when my pencil breaks. Is found by multiplying by a constant number. Okay, so this sequence, it's kind of like with the arithmetic. Arithmetic, everything we did dealt with addition, correct? We added positive numbers, we added negative numbers. Okay, so everything was adding. Now we're doing the same thing, except for these sequences are going to be multiplied. And every time it's going to be multiplied. Before, we had the following. We had this, a(n) equals d, our common difference. And then we had n minus 1 plus a1, which was our first term. So we had that common difference. Well, now we have a common ratio. Okay, the common ratio is the number that we multiply by. Okay, that is, so we multiply by each time, each term, by each time, each term, okay? So that is the number we use. Here's the key though, you gotta make sure that you remember this. You cannot use division, okay? Just like we could not use subtraction, we cannot, absolutely positively cannot use division here, okay? So let's try a couple problems. I think it will come to you, and we'll have our own formula that we find here shortly. So looking at these directions. So to determine if the sequence is geometric, okay, that's the first part. So let's figure that out. And then if yes, find the common ratio, okay? So let's see here. We went from 2 to 8. What did we do from 2 to 8? We multiplied by 4, okay? We may need to even look at more than one term because when these are close by, sometimes it's like, oh, they're adding this. Well, if I know I'm looking at a geometric sequence, I know I'm not going to be adding anything. I would be multiplying. What did we do? Go from 8 to 32. We also multiplied by 4. Okay, 32 to 128 is multiplying by 4 as well. And you can double check that by taking 32 times 32 times 4 in your calculator and you will get 128. So is it a geometric sequence? Yes, it is. And our ratio, which is going to be the letter R, not to be confused with radius, is going to be 4. Okay? So the next one, well, let's see here. I went from 1 to 5. Well, that would make me think it would be times 5, but let's double check. I'm going to go to the next one. This looks like 5 to 9. 5 to 9, the only way to get there is nothing with multiplication. It would be adding 4, which would make sense as to how we got from 1 to 5. And then 9 to 13 looks like an add 4. So this is an arithmetic sequence, not a geometric sequence. Okay? If we look at the next one, we went from 1 to 2. Well, that could be multiplied by 2, but the 2 to 3 looks like we're adding 1. The 3 to 5 is adding 2, and the 5 to 8 is adding 3. Once again, we do not have a geometric sequence here. Okay? Up next, we have, oh, that's interesting. Will you take a peek with me? I'm going to zoom in a little bit on this question. Okay, so notice what the numbers do. So far, when we've had geometric sequences, our numbers have gone up. Okay, now we have a case where our number, don't pay attention right now to the negative or positive, but the number is actually getting smaller. Okay, this is what we were talking about. You cannot use division. The equivalent of that is we're going to multiply by a fraction. Now, I know many of you are afraid of fractions. When I recorded this video, it's near Halloween time, and I thought it would be funny to dress up as a fraction. I wonder how many people would run away from the door scared if when they opened the door you saw somebody in a fraction costume. I don't know. So here's our funny little things. So we know it's going to be a fraction. Okay, and in this case, it is going to be a geometric sequence. Okay, I'm giving away that secret. So I'm going to look here, and what did I multiply by to get from 5 to 20 and 20 to 80? I dealt with the number 4. Okay, notice where I'm putting this right now. You can always check with your calculator as 2, but we know it's going to be a fraction because it's going down. Well, we're going to multiply it by 1/4. Okay, and you can check this out. Take 320 and multiply by 1/4 and you would get 80. Now here's the extra thing. I use the term flip-flop, but notice we go from a negative to a positive and then to a negative and then to a positive. So this means that we're going to be multiplying by a negative number. Well, how do I know that? Well, if you remember, if I have a positive times a negative, I have different signs here. That's going to be a negative number. And when I have a negative times a negative, it's going to be a positive number. So that is why we do the flip-flop. So whenever you see negative, positive, you know that the ratio is going to be negative. Okay? Once again, if I see that my numbers are going down, I know I'm going to be dealing with a fraction. Okay? In most cases, that we're going to deal with, your fraction is going to start with a 1 on top. Okay? If you can figure out what, and you can even use your calculator this way, take 320 divided by 80. You don't even have to include the negative, but just number to number, and you find out it's 4, then I know that's going to be my denominator. Okay, so the answer here is yes, and the ratio, the common ratio, is going to be negative 1/4. Okay, don't let that confuse you. We do have it come up occasionally, but I want you to be aware of how that works. Okay, for questions 5 through 7, these are pretty simple. We're going to find the next 2 terms in the sequence. So first I'm going to look and see, oh, I have negative, negative, negative. So I'm not going to need to multiply by negative, because if I do, just like what we had up here, I'm going to end up with a positive number, and it needs to stay negative. So what times negative 4 makes negative 24? Well, that would be 6. And negative 24 times 6 is also going to be negative 144. So I'm going to set my calculator here. Let's turn this on. And let's do negative 144 times 6. And I get negative 864. And then I'm going to take that times 6. And we get negative 5,184. Okay? So that's how we do that part. Without actually going through all of these, what do I notice about number 6? I'll zoom in for you. Okay, so on number 6, I notice that my numbers are going down. Okay, so I know I'm going to be dealing with a fraction of some sort. If I don't know 200 to 40, I do know that 40 to 8 is I'm dividing by 5 if I divide it, but we can't divide here. Or 8 times 5 makes 40. I look at it going the opposite way. So we're going to have a 5 on the bottom, and it happens to be 1/5. Okay, I'm not doing any flip-flopping here with my signs. So we can take 8 times 1/5. Oops. Let's go back into our current. So we can take 8 times 1/5. And we get 8/5. And then we're going to take that 8/5 there times 1/5 again. Okay? and we get 8 over 25. Okay, you try number 7 yourself and pause the video. Okay, you should have come up with, hey, how do I get from 6 to 2? When I deal with these, I like to just kind of look at the numbers themselves. I don't worry about the negatives and positives. So what times 2 makes 6? It happens to be 3. And I did notice that, hey, I'm moving up. 6 times 3 is going to give me 18. And 18 times 3 is going to be 54. Okay. I do notice that, hey, I go from positive to negative to positive to negative. So I'm going to be multiplying by a negative 3. So negative 54 times negative 3. And then that number times negative 53. Or excuse me, times negative 3. My bad. So I'm going to have 162. And then times that negative 3 again is going to give me a negative 486. Okay, so let's look at the next page. And now we're going to actually use our geometric sequence formula. Okay, as I mentioned on the previous page, we have a formula that we use. And this is what our formula is for geometric sequences. We have Gn, though in some places you see it as An. Okay, our arithmetic we use An. But there are some cases where they're going to label it as that. But Gn is usually for geometric because we realize it's going to be that way. We're going to use our first term, G1. We're going to multiply that by that common ratio. And then we're going to still use that n minus 1 that we used in the other one. But this time it's going to go up here in exponent land above our r. Okay? So G1 is your first term, and our R is our common ratio. Okay? So, for directions 8 through 10, it says write the rule for the nth term. Okay, so we're going to use that formula to write the rule. And then we're going to find the 12th term. So let's look here at number 8. As we did before, let's find our ratio and let's find our first term and write them down here. Okay? So we have 1, 3, 9, and 27. Well, I know that 1 times 3 gives me 3. 3 times 3 gives me 9. And 3 times 9 gives me 27. So my ratio is going to be a positive 3, and my G1 happens to be this 1 right here. So let's write our rule. We're going to have Gn equals, I write my first term down, which is the number 1, and then I'm going to do a parentheses, because we can use parentheses, we don't always have to do the dot, and I'm going to write my ratio, which is 3, parentheses, n minus 1. Unlike our arithmetic, we do not have to distribute and combine like terms. That right there is your rule. Okay? So, here's the work that you do need to show. We have Gn equals 1 parentheses 3, and we're looking for the 12th term. Okay, so let's actually change out this n and make it 12. So I'm going to have 12 minus 1 in exponent land. So I end up with 1 parentheses 3. 12 minus 1 is 11. So in your calculator, we're going to type in exactly what we see. Okay, we're going to type in the number 1, parentheses, 3. Go on the other side of the parentheses. You're going to have to hit the right arrow. And then you're going to hit caret, which is by the number 4 here. And we're going to pick 11. When you hit enter, you're going to get a ginormous number. So G12 is going to be 177,192 147. Okay? So, be aware when we did arithmetic, a lot of our problems we were adding 2, we were adding 3, even 5 or so. So the numbers are going to stay smaller unless you ask for a ginormous or a gigantic term, like you want to know the 350th term in the sequence. But when we're dealing with multiplication, whether it be a whole number, like this one, or whether it be a fraction, okay, then our numbers are going to be possibly really small or they're going to be huge. Okay, so let's try number 9. Number 9 is the same. We've got a ratio here and we've got G1. My ratio, I went from 4 to 16 and 16 to 64. Well, I know that 4 times 4 gives me 16, and I know that 4 times 16 gives me 64. So I'm going to be dealing with a 4 here. But I also notice that, hey, I have a negative there. It's positive, and then we have a negative. So I'm going to be multiplying by a negative 4. If you're not sure, go ahead and try it in your calculator. You've got negative 4 times negative 4 gives you a positive 16. Positive 16 times negative 4 gives you a negative 64. So you can always test those out by plugging it in your calculator. Okay, if you can't do it in your head or you're not familiar with it, do that, please. What is my first term? My first term is this negative 4. So let's create our rule. This rule is going to be specific to this problem. Just remember that when you're writing these rules, they're specific to this problem. So I have Gn equals, my first term is going to be negative 4, right? It's my first term. I'm going to do a parentheses. I'm going to put in my ratio, my common ratio, which is also negative 4. And then I have n minus 1, and it is in exponent land. Okay? That's what I like to say. So that is my rule for this geometric sequence. So now, once again, we're trying to find the 12th term. So we're going to find G12, and it's going to be equal to negative 4, parentheses, negative 4. Okay, I'm just copying down what I see here. And then I'm going to have 12 minus 1. So I can go ahead and figure this out and show some work by saying negative 4 stays here. Remember, we're not going to multiply these two negative 4's together. Our order for PEMDAS is, hey, you're going to do things inside the parentheses. I don't have anything to do there. Then I'm going to do my exponents. Okay? So that would be the next thing you would do. So we can do it in our calculator by saying parentheses negative 4 and then saying 11. And we get a giant number. So this can be negative 4 times negative 4,194,304. Okay, so this would be a way of showing work. But our final answer would be that number times negative 4, which is going to give us a positive 16,777,216. Big number, huge number. Like I said, we will sometimes get a really small fraction. Sometimes we will get a really big number, like in this case, depending on how many terms you need and what your common ratio is. Okay? So, try number 10. Before I move on, try number 10 and take a peek. What are my numbers doing? Notice they are going down and they are flipping back and forth, that flip-flop between a negative and a positive. Okay? For questions 11 through 14, you're going to do the same thing. You're going to practice writing the rule using our formula. Gn equals G1 times R. N minus 1 is an exponent land. And then we're going to find the 8th term here. Okay? So do be aware there is a difference between the 8th term and then the ones up here were the 12th term. Okay, so do make sure that you pay attention to that little bit. I'm going to complete the geometric sequence notes in another video talking about the word problems. Thanks for watching.